Hello, my name is Jessica Hamilton. I'm a geochemist working at the Australian synchrotron, where I research the chemistry of metals in mine tailings and the environment. Well, I was always told not to become a teacher because I come from a long line of teachers, and at least here it's an undervalued profession. But I really had no idea what I wanted to do. Later in life, I realised I just want to do cool science with great people, and I think I'm doing that. Take a look around you right now. Whatever you can see, if it wasn't grown, it was mined. The mining industry produces the raw materials for the buildings that we're in, the products we buy, and the technology that we need to transition to a low-carbon future. But mining also has some serious waste problems. Mineral wastes are just stockpiled in massive heaps. Waste acid is an environmental risk that costs millions to neutralise, and the industry is a big CO2 emitter. Now, too often we tend to pitch environmental values and economic values against each other. But this conversation is not going to do that. It's going to be about harmonising both together. And it starts with this question. What if we start thinking about all of these wastes as resources? By combining them, we can create valuable products and offset CO2 emissions. In my PhD, I demonstrated a low-cost process to put this idea into practice and to break the wall of recycling CO2 in mining. So, how does it work? Well, first we target mines that have rocks rich in magnesium and calcium. If we irrigate their mineral wastes with acid, the minerals dissolve and we get water rich in magnesium and calcium. When that reacts with CO2, it forms carbonate minerals. Now, carbonates are environmentally safe, and they're used in industries from construction to pharmaceuticals. My research also showed that during that acid leaching process, valuable trace metals within the mineral wastes accumulate in a concentrated layer. So you can see that by reusing all of these wastes, we can neutralise that acid, capture CO2 in valuable carbonates, and transform stockpiles of mineral waste into an enriched ore that could be remined. You might be wondering, why has no one done this before? Well, previous research has really focused on maximising conversion rates and has relied on engineered reactors with high temperatures, pressures and chemicals. So far, no economically viable process has been developed. In my work, rather than striving for 100% conversion, I instead looked for really low energy and low cost technologies that could be repurposed for this and could be implemented immediately. I scaled up experiments from the lab to the field, and the outcomes of that work are now contributing to a testing program for diamond mines in Africa and Canada that aims to achieve the first carbon neutral mine in the world. So by changing the way we think and seeing CO2 not just as a problem, but also as a solution, we can transform the waste process and squeeze out as much economic and environmental value as we can, while feeding into growing markets for low carbon raw materials. This is the future of mining. That we can turn mine waste into products while offsetting CO2, and we can do it using existing technology in a low cost and low energy input way. Well, reducing emissions in every way that we can will benefit us all, but this is also an opportunity to reduce the environmental cost of producing the technology and the products that we all own and use every day. Well, this solution will look a little bit different at every site because it depends on the availability and the chemistry of the waste and the value of the products that can be produced. So every mine will need some initial scoping and test work to adapt and optimise this process depending on those variables.